All right, welcome to day 8, our review day for this unit. We're going to go over the 3 homework problems. There's no warm-up. And then we're going to do 3 of the review problems, leaving the rest of the problems for you to do on your own, and then check the worked out answers on Schoology. So the first one, to prove these are congruent by basic rigid motions, we first want to translate our triangles. I chose to take triangle ABC and translate it to the right. So we wanted to translate it the length from C to D. You could have also said the length from A to F for that as well. And then we would need a reflection, so a little r over line FD. Now when we have our givens, we have AF congruent to DC. So you should be suspicious about that because AF and DC are not sides in the triangle. That's what should lead us to think, oh, we're going to have to do some addition here because AF is short of a full side. So our initial things that we were given, we had those, great, we got a side in the triangles. We had those, great, we got an angle in the triangles. But we have these segments here from D to C and A to F, and that's not a side in the triangle. So what we need to do is first say that FC is congruent to itself by the reflexive property. So now we've got that congruent to itself, and we're going to do some segment addition. So the segment addition postulate, 3 words, each of them has 3 parts. That's how I like to remember it. So add the AF and the FC congruent to AC. Add the CD and the FC congruent to FD. Now next would be the addition postulate. I like to think of it as 2 words here. Each side has 2. That's what helps me remember. So you've got the AF plus FC is congruent to the CD plus FC. And then the last step always in our addition or subtraction sequence is substitution, giving us what we want. The whole segment AC congruent to the whole segment FD, and that gives us side, angle, side, and our triangles congruent. In our next one, the basic rigid motion is a pretty easy one here. We're going to rotate around about point D 180 degrees and just pick one of your triangles. I picked BHD. You could have picked the other triangle as well. So the thing we should be suspicious about in this one is that they gave us HC and JB congruent. Those are not sides in our triangle. That's too much of a side. So it's too much of a side, so we want to think segment subtraction. We were given AD and JD, so that's a side in our triangle, and then you could do vertical angles to get a set of angles there. But what we're going to have to do is take that HC and subtract off HD, and that will give us DC. And then similar idea, take the JB minus the JD to give us DB. Those each had 3 parts, 3 words, segment, subtraction, postulate. So then we'll put the double ones congruent to each other. That's the subtraction postulate. And then lastly is always substitution, and it should be what you wanted to end up with. We wanted the DC congruent to the DB. So that's that one and that one. And now we have side, angle, side, congruent to side, angle, side, getting our triangles congruent. Our next one, 2 things we should be suspicious about. Angle 1 and angle 2 are not in our triangles that we want at all. And those perpendicular lines giving us right angles, well, that right angle is not going to be in our triangle at all. But before we get to that, we can do the basic rigid motion by just reflecting over Sn. That would flip the triangle onto the other one. So that was a pretty straightforward one. So in our givens, the things that help us in the triangle, we had those congruent, we had these angles. But that was only, sorry, we did not have those angles. Those are the ones we eventually got. We had those 2 sets of sides congruent. And then we could do the perpendicular lines to get the right angles, and then we'll have to subtract off angles 1 and 2 to get angles 3 and 4. So there's in step 5, our perpendicular lines gives us our right angles. We get those 2 right angles, have to name them with 3 letters. Then right angles gives you those are congruent. do those right angles minus angle 1 and angle 2, doing your angle subtraction postulate. Set the double sides congruent to each other in step 8 for your subtraction postulate. And then the actual angles we want, 3 and 4, are in step 9 by substitution. And that allows us to say our triangles are congruent by side, angle, side. So the review pages start on page 35. You will want to do all of the problems. So that altogether there are 9 review problems. You'll want to do all 9 before the test. We are going to do 3 of them together. The rest of them you'll do on your own. And then if you go to Schoology, Class Materials, Unit 7, in there is the worked out review solutions, so you can check your answers. So that will be part of what you're doing the rest of your Wednesday. So the first one we're going to do together is number 4. So if you could flip to that. So on number 4, we'll start with our givens. So in those givens, nothing was congruent. We're just trying to get those 2 triangles congruent that are in the picture. So maybe let's start with the midpoint. So hopefully we automatically know to do midpoint implies 2 congruent segments. M was the midpoint, so our 2 congruent segments will be WM and MQ. And then we've got isosceles triangle. So we can do isosceles triangle implies 2 congruent sides. That'll give us WA and AQ. And we can also do isosceles triangle implies 2 congruent base angles. So if we think of the big triangle, the congruent sides are those double tick marks. So the angles across from those are the W and the Q. Or you can use the fact that they told you the base was WQ to know that W and Q are the base angles. So angle W is congruent to angle Q. And we'll mark that in the picture. And notice we have an angle in between 2 sides, so that's side angle side is congruent to side angle side. And our statement is just what we wanted to prove, the triangle WAM is congruent to triangle QAM. Now there was another option here. You could have, if you wanted, instead of what we had for step 5, you could have done a reflexive property and got side, side, side. However, you could not have replaced step 4 with reflexive property because that would have given you side, side angle, which doesn't work. All right, so that was 4. Next one we're going to do is 7. Oh, I forgot to, let's go back to 4 for a second. I forgot to have us do our basic rigid motion. So we would want to just reflect. So we'll do little r for reflect. We're going to reflect over MA. And the thing we're reflecting is one of our triangles. So triangle MWA, we'll say. And remember, I always like to write them with the transformation notation. You can just write out a sentence in words saying what the transformation would need to be, and that's perfectly fine as well. So we're going to go to 7 now. So go ahead and get your givens down. And let's see if we can identify the triangles we want to get, because there's a bunch of triangles in the pictures here. So RQY and TQX. So those two triangles. So for our basic rigid motion, how we could get this, we would essentially need to reflect over that, and it would reflect onto itself. Well, that would be tough to write with our notation, so we're just going to write it out in sentences. We're going to say reflect triangle RQY over, and what that would be is it would be the bisector of angle Q. The bisector of angle Q. So because we didn't actually have that segment there, we couldn't really write it with our notation very easily. All right, so first thing I want you to notice is angle Q got traced twice. So we haven't seen it a lot. We'll see it much more frequently in later units, but when things are shared, that's reflexive, and you can share angles. So we're going to have angle Q is congruent to angle Q by the reflexive property. Now, before we get too far, we should mark up our givens. We have QX, so that one is congruent to QY in the blue one. We just did our reflexive property, so we have a side and an angle from those. And then we had XR and YT. So XR was saying this one here, and YT is saying that one there. Well, that should raise a red flag. It should raise a red flag because those are not sides in the triangles that we're working with. They are too short to be sides in the triangles. So to get them to be sides in our triangles, we need to add on. What we're going to do is we're going to add on the QY to the YT, and that'll give us another side in the green one. And we can add on the QX to the XR, and that'll give us another side in the blue one, which would then give us side angle side in each triangle. So that's our plan. So we'll start out, we'll take the QY plus the YT, and that's congruent when you add them together to QT. Going on the other side, we'll take the QX plus the XR. And when we add those together, that's going to give us the QR. Each of them has 3 parts, so we should have 3 words in our statement. We were working with segments. Our operation was addition. And then postulate. We always follow that up by making congruent to each other the sides that had 2 things on them. So we'll just carry down QY plus YT is congruent to QX plus XR. Now I always like to remember each side has 2 things, so we should have 2 words in our reason here. This is just the addition postulate. And then our last one in the 3-step sequence with addition and subtraction is always just what we were trying to get. We were trying to get QT to be congruent to QR, and the reason is always substitution. So that gave us that long red side, so we now have side angle side in each triangle to get us the triangles that we want. So we'll have our SAS congruent to SAS, and we had triangle RQY is congruent to triangle TQX. So the last one we're going to look at in this video is number 9. So if you could flip ahead to that. We're going to eventually get KNL, the left-hand triangle, congruent to MNL. So for our basic rigid motion, this is a pretty simple one. We're just going to reflect over LN and pick one of your triangles. So we'll say triangle KLN. And then we'll go ahead and we'll throw our given statements in there. So our first given talks about an altitude. Let's go ahead, we'll do our altitude reason. Altitude of a triangle implies perpendicular lines. We're pointing at perpendicular lines, so we need to say which are perpendicular. Well, LN's the altitude, so that has to be one of them. So LN is perpendicular to. And just see where does LN then meet with a right angle? Where does it make that upside down capital T? Well, that's KM. So we've got perpendicular. So next reason we should talk about perpendicular lines. We know perpendicular lines imply right angles. And we're pointing at right angles, so we got to say which ones are right angles. Well, it's where LN and KM meet. So let's go ahead and number those, 1 and 2. You can say angle 1 and angle to our right. Well, we just said that we had right angles. Let's do our right angles reason. Right angles implies congruent angles. So we just say which ones are congruent. Angle 1 is congruent to angle 2. So we can mark that in our picture because we've got those congruent, and that's one set of angles in our triangles. Let's go to our next given. We've got a bisector. The thing coming after the word bisector is a segment, so we'll be using our segment bisector reason. So segment bisector implies midpoint. We're pointing at midpoint, so we've got to state what the midpoint is and of what. So we have n is the midpoint. Of km. We just talked about midpoint in this statement. So next reason, we should use our midpoint reason. Midpoint implies two congruent segments. We're pointing at two congruent segments, so state which segments are congruent. Well, if n is right in the middle of km, that's going to give us kn congruent to nm. And because we said something's congruent, we'll mark it in our picture. We are out of givens. We've used all our givens. When you run out of givens, look in your picture, see if you have vertical angles, which are formed by crisscrossing lines, or reflexive when things are shared. We have reflexive in this case, so we're going to say that ln is congruent to ln by the reflexive property. And if we look at our picture now, we have an angle in between two sides. So angle in between two sides will be side angle side, congruent to side angle side. And then our statement is just what we wanted to prove, KNL and MNL for our triangles. So you've got 6 other proofs to do on this sheet. Make sure to tell your basic rigid motion that would make it happen, and then also to do the proof. Once you've done each of them, or if you get stuck on any of them, go to Schoology, go to the class materials folder, and then Unit 7, and you'll see a link there for the file for the worked out solutions for the review. So you can check your answers and go through that. You can also come to the office hours today for your class period if you need some help at all with the proofs. Have a great rest of your day.